In Chapter 73, we're talking about sequences or patterns again, and the formulas we can use to simplify finding the number in a particular pattern. But you don't have to come up with the formula, you just have to be able to use the formula today. Recall we use terms like variables like n and a when we work with sequences. N refers to the number in the sequence. First, second, third, fourth, fifth, sixth, seventh term. That's the place, the number, the location in the list. Then the value is a. So the first term is literally 3. Second term is 6, 9, 12. And you might be able to tell the pattern here is simply add 3 every time. So the fifth term's value, A5, is 15, 18, 21, and so on. We can write a formula, and luckily today they give it to you. The value of a particular place, n, is 3 times its position. Not times the value, but times its position. Okay? I'll show you how we use this. If they wanted to ask, what's the 7th term? Use this formula to find the 7th term really quick. The value of the 7th term is 3 times 7. N, or position, is 7. So the 7th value is 21. And it was. We just plug in using the values n and a that we are given. In example 1, they say 8th and 9th term for this formula. We don't even need to see the list. We just need to know the formula. A to the subscript 8, or 8th term, is 3 times 8. N, anywhere you see n, you stick in an 8. I see an n here. Now for the 9th term, I do 3, and there's an n, 9. Okay? Using this formula, I plugged in 8 and 9, my two n's. 3 times 8 is 24. 3 times 9 is 27. Just plugging in where you're given values for n. Sometimes patterns are not super simple. In example 2, they just say find the next two terms. We're not using formulas here. But in letter A, we're going to have to figure out what the pattern is, right? And it's pretty simple. It's just always multiply by 2. That position by 2. So 2 times 2 is 4, 8. 32 times 2 is 64. Then you take 64 times 2 and it's 128. Just keep multiplying by 2. In B, each term is the sum of the two previous terms. See, that's a little bit different. There's 1, so it's still 1 because we don't have a previous term. Maybe think of it as 0. 0 plus 1 is 1. Then this, what's the pattern? It's these two added together. What's this? It's the previous two terms added together, and so on. And finally, C, it actually alternates between subtract 3, add 4, back 3, forward 4, back 3, forward 4, and we slowly get further. Very different type of pattern. Remember example 2 in case you get stuck and you can't figure out a pattern. Maybe it's similar to one of those. Okay, back to using the formulas. Example 3, 2a's formula is the position of a is 2 times position number. Find the 10th term. 10th is 2 to the 10th. As it shows here, we just plugged in n as 10 in the formula they gave us. You would type in 2, and if you've got this y, you can't really read it on my computer, but y to the x, you could hit that and then type in 1, 0, or 10 equals. So you hit the number you want, 2, and the y equals, or maybe it's a caret, either one, then you put this in, it counts as a exponent. That means 2 to the 10th, or 1024. 1024. Find the first 3 terms of the sequence given by this formula. The only change, they add 1 every time. So first term, you put 1 in where there's an n. So that ends up being 3. Second term, is 1 plus 2 second, 5, and then the last one will be 7. You can kind of see it's a pretty basic pattern there. There's something called a triangular number. Reminds me of shooting pool. Kind of a complicated pattern I'd probably never figure out just by looking at this. But they give you the formula, and then they say, what's the 10th number? To find that, you would put, technically you put a 10 here. The value of 10 is 10 times 11 divided by 2. 110 divided by 2 is 55 would be the value of the 10th number. See how much faster that is than trying to crack the pattern and then list the other 9 numbers? Why don't you do letter A to get warmed up, C, and D. A, C,